Good morning, everyone. Thank you for being here, for joining us today for the Autodesk Virtual Academy by KETIV Technologies ourselves. I'm Nigel Mbike, as has been the case for, I guess, the last 6 months. And I'm joined here by Jorge Fernandez and Wayne Griffenberg. Wayne, hello.
Hi guys, thanks for having me on.
For sure. So before we get started here with the actual demo for those of you who don't know, Fusion 360 from CAD to CAM with Wayne. I'm gonna go over a couple of things first. We do have an event on October 19th at the Bowers Museum in Southern California, and it's kind of about what's new in manufacturing. Not necessarily that, but a little deeper into that. So we understand that there are a lot of innovations in technology, and part of the manufacturing world, you kind of have to be at the tip of that, make sure you're ahead of the competition. And Autodesk does have solutions to go ahead and help you be at the spearhead of technology. And Amar, who's Autodesk Senior Vice President of Products, is going to be speaking. Jorge, do you want to?
I think we all know manufacturing is changing a lot, as well as the way customers want their products and so forth. And those are things that you worry about every day, right? And Amar is really one of the visionaries at Autodesk that is responsible for a lot of this new technology that's coming to us. So this is one of those rare opportunities to be able to have someone like Amar, where he's out visiting, he's at the forefront, visiting companies, looking at technology, looking at things that we should embrace. Not just at Autodesk and the reseller channel, but also as customers, things that you can take advantage of today and in the future, as well as a lot of the things we've been seeing recently, right? So those are the types of things you'll be able to get from Amar. Again, this is a great opportunity. It's not something that's just every week or even every month that we get to have someone like Amar join us for an event. So it'll be very important to sign up and make sure you reserve your spot if you're serious about going.
And I'm sure Wayne, you can attest to this. Amar is a very busy guy. It's like kind of a special treat for people for him to actually be there.
Yeah.
Yep, agreed. Yeah, it's great to hear him talk. He talks about our product innovation platform, talking about the future of making things, and it's really great to see, how he talks about a collaborative design, being able to have flexible manufacturing, whether you're doing additive or subtractive. Talk about his experiences on bringing this to the customer and bringing it right back around to that personal ability to be able to design your products. Really great experience to be able to hear him talk.
Definitely, for sure. So with that, and even then, some of the stuff we're going to go over today is part of that. So kind of ties into, what we're doing today. With that, I'm going to go ahead and introduce Wayne. Wayne Griffenberg is one of the CAM solutions engineers over at Autodesk. So Wayne works in all of the CAM tools, ranging from Hsm all the way down to even stuff like what we're going to do today, Fusion CAM. Great guy. I met Wayne, a couple of weeks ago via e-meet. I had a session with him the other day, and it's pretty awesome. You guys are in for a treat today for sure. So we're going to go through Fusion. The greatest thing about Fusion is, some of you might be using it already, but for those of you who have Product Design Suite and Product Design Collections, you already have the tools. So why not learn how to use some of the tools you already own? And it can do so much stuff. I know that even 5 years ago when I was working in college, some of the stuff that Wayne was showing me was impossible to do in the software that I was using. So with that, I'm going to go ahead and pass it on to Wayne.
All right, awesome. Thanks, guys. So I'm going to bring up my web browser. Now, as we were talking about that product innovation platform within Autodesk and all of our products, being able to design your product, bring it all the way through to be able to make that product. And today's flexible way of working with our collaborative design, and part of that being able to 3D print your part or machine your part. Today we're going to focus on that machining part and working through A360 on being able, our projects in A360 and working through Fusion 360 to be able to design, or in this case, make that part that we have designed. So I just want to show you the interface right here. I'm going to bring up my hub. When you work with Fusion, you're going to work with A360. You'll get your account. You're able to create your projects and work with projects and share them and collaborate with people across the world. Here's some projects that I work on, some basic projects for training and working with other teams. I have a lot of them where I can see these projects, where all my projects people have shared with me in the past, ones that I work with all the time. And I can take a look at those projects, but you can also notice over here where I have a history of things that are happening, activity that's happening in these projects, not only by me, but also people that I'm working with and collaborating with. I can take a look at some of those things. Here, Josh has uploaded this turning part, one of the turning parts that we use when we're teaching CAM. And you can see it has the toolpaths on it. I can actually see design, and I can see the history of the design as well as the CAM that's on the part. We're going to get into that, putting CAM on, not really turning, but on the milling side. But I'm able to see the part. I'm able to work with this part. I can get some properties off the part, get some idea of what it is. I just grabbed the stock model there. I can also get sections off the part itself. This is in my browser. I'm able to pull this out, see what it looks like in a cross-section view of the part. I can also get an angled cross-section like this. So you can really flexible right inside your browser, being able to see this part, to be able to work with it and get a good idea. I can also collaborate, and I can leave, so I can mark up and I can add some notes and comments onto the part or into a position on the part where I can leave it for Josh to look at and say, check this part out, make sure it's okay. So I'm going to go right back into the home. This is my main screen. I can go into any of these projects. If I look in this project, I can see the folders and parts that I'm working on. If I go a little bit deeper, I can see components and parts. I can also see the people that I'm working with, almost like a social media kind of interface here that I can edit some information. I also have different hubs. This is my home hub. I'm going to switch over to another hub where I share information with our CAM team. This is the actual collaboration folders that I use to share with our team as we go to do training across the U.S., different areas that we work with. I actually work and collaborate with our team who, Tim is over in California, Matt's in St. Louis. We can do live updates. We can look at each other's parts. We can look at customer parts. We can communicate right through this tool. I'm going to go into open up our training files that we use. Right here, I can see this interface. I can also change it so I can see what the components look like. Again, I can open up and get an overview of those parts. Right now, this is what I actually have on a VF2 machine. I have a couple of these vices that I downloaded from the vendor. This is orange vices. You can download them from your vendor's website, upload them through A360. You can also upload them through Fusion 360, and it'll convert the models for you that you can use them inside of Fusion. Again, I can open up, I can get an overview of this assembly, I can view it, I can explode it if I wanted to, do something like this and explode the model if it already had an exploded view. I can do these things right here. I'd like to open it so I can show you. So I'm going to go open in Fusion. So I'm going to open this assembly. It'll give me a second. It's going to open up that assembly in Fusion. As long as I have access to it, I'm going to make sure I do a backup of this. So as long as I have access to this project, I can go in here and make changes and edit it. It looks like I might have lost my little CAM tab here. Let's see. It's only when I'm doing a webinar I lose it. That's okay. All I'm going to do is I'm going to close it out real quick. I think I just recently did an update, and I've seen this before on an update. So I'm going to close out. I'm not going to save it. That happens. I'm going to open it back up again real quick. Sometimes the software will crash. Sometimes that happens. But one of the great things about Fusion, and I'll show you as we're walking through the CAM, that you can get right back to where you were really quickly if it does crash. You'll be able to open up your files and get right through your CAM files as well. So here's another way to get to that same file. I can go and open up this data panel right here. I can expand that down, and I can also change the hub right here like you saw me do on the web interface. I can change it here. I'm going to go into that CAM. I'm going to go into my technical training files, my Fusion training files, 2D machining, get right back to where I was, and open it up right from inside of Fusion. So I don't have to go through the web interface. I can do it right here. So I'm going to right-click, go to Open. It's going to open up that assembly that I can work with. And as soon as I open it up, it gives me some information that something has changed. I already actually have some toolpaths, so I'm going to restart them. I'm going to delete those out. All I did was right-click and hit delete because I want to start from fresh and I want to show you what I'm going to do with this. So if I go back into Model, it shows me right here that I have some updated components. Something has changed on these parts, and I want to make sure I have the latest one. This link means that they're linked to another place in my project, or they could even be linked to somebody else's project, and they're updating it, and I want to make sure I get the latest update. So I click this Update. Goes through, gets me the latest part, updates it. You saw it changed, it stretched, and now I have more holes in here. So now I have the latest part that I'm working on. So this is what I want to make on my machine. So right now I have these two orange vices sitting on the Haas VF2. I have a block of aluminum sitting right in this jaw, right inside that soft jaw. In fact, if you do set up your assemblies like this, you can use the assembly to drive your fixtures. You can actually create your soft jaws right from here. So this is what I want to do, is I want to mimic what's going on in my machine, and I have a block of aluminum right there. So I'm going to switch over to the CAM tab. So I'm going to go in here and I'm going to mimic that. So working from left to right, this is our CAM tab. We have all the information we need, all the features and functions we need to be able to create this part on our machine. So I'm going to go to Setup. We have the In Context Help. I click Setup, and the first thing it does, it recognizes everything in the graphics view. It says, is this all this what you want to cut? Well, if it is, this is the minimum stock that you need to do that. Well, I don't want to cut all my vise, so I'm going to hit this little X here, and I'm only going to choose that one part. And it shrinks that minimum stock size down only to that one part that I'm going to make. Let me move this over a little bit. I'm going to take my browser, I'm going to lock that over here. I like to have this out so I can show it a little bit better. So what I'd like to do is mimic what's on my machine. So it has this part. What I want to do is I want to set my G54 up in the corner there so I can touch off and probe on that corner of my stock. So I'm going to choose box point, and I can select any point on my stock to be my G54. Really quick and easy. So my orientation, if I wanted to have a horizontal, right now my Z is up. If I want to change that orientation, I can simply select the face. It'll rotate that orientation according to that face. Really easy to use. My stock size, I'm going to add in here. I can use different, if I had a solid that represents my stock, perhaps I have a forging or a casting, you could select that solid right off the screen. In this case, I'm going to select a relative size box. I'm going to add an 1/8 of an inch around it. You see it grow right inside the graphics view. I'm going to add a 1/10 on the top, and I want a 1/4 inch going into my soft jaw. So it's a little bit bigger. I'm going to have to edit the part. I just realized I have the bigger part. I'm going to have to change it to make it smaller. But I can also change the soft jaw geometry as well to match the part. So in this case, I added my relative size. It gives me the relative size stock that I would need. I'm going to say OK. Calculates. OK, now I have my stock with my offset right there that I'm going to use. Okay, the first thing I want to do is I want to trim off the top face of it with a face mill. So I'm going to go up to my 2D toolpath. I'm going to choose the face mill. So I'm going to choose a face operation. This workflow right here, this same workflow you're going to see in every single one of our toolpaths. Really easy to learn, easy to use. That workflow, you're going to see it over and over. Your tool, geometry, heights, passes, and linking. So the first thing I'm going to do is I'm going to select my tool, go to select. This nice interface to be able to work with the tool. This is our tool library for Fusion. I'm going to work through it. It knows that I'm doing a face operation, so it filtered on operation for face. It knows what tools make sense for a face operation, so it filtered on those. I'm going to filter down a little bit more, and I'm going to choose a face mill. It shows me that right here in the graphics view. If I needed to make a change, I can edit that tool right now on the fly, and I can change any aspect of that tool to match what's in my machine. I can update the feeds and speeds right here on the fly. I'm going to say OK, select it, brings it into my graphics view, right inside of Fusion. And I'm going to leave everything else out of the box. My next step would normally be selecting geometry, but I don't have to, because when I did my job setup, it recognized where the top of the part is, and it knows where the edge of the stock is, so it knows exactly where to put the toolpath. And there I have a face toolpath. Okay, I want to see what that's going to look like before I move on to the next step. So while I have it highlighted, I'm going to go up here to simulate. I can simulate right on the part, and I can see what that's going to look like before I go to cut. I can even see it as if I had stock on the part. So if I pause this, I go to add stock, I can see what it's going to look like. Let me change this so you can see it a little bit better. I'm going to change it to a ceramic material, sorry, so you can see it a little bit better on your screen. And when I play through, you can actually see what that tool is going to do as it's cutting that material right on the part, right inside of Fusion. Complete integration. I don't have to leave this environment. It shows me right there. Okay, I'm going to close out. The next thing I want to do is I want to cut these pockets out. So I'm going to go up and grab a 2D adaptive clearing. Really good algorithm for clearing chips really efficiently. Okay, the same workflow. Working from left to right, choose a tool. And remember the last tool that I used. So I'm going to select the 1/4 inch roughing mill right here, my 3-flute roughing mill. Brings it in. I can see what it's going to look like. The geometry, what do I want to cut? That's the next tab. Well, I want to cut this edge right here. So by selecting the edge, it grabs that whole boundary. And if I selected this face, I could select the face. It'll say, do you want to do outside or inside of the face? Well, I really don't want to do the face. I want to do this open pocket, so I select it again and get rid of that selection. I want to get this edge, and it recognizes it as an open pocket. It knows that's the area I want to machine. The same thing on this side. I'm selecting those open pockets, and now I'm selecting the closed pocket. And it doesn't matter if they're at different heights, it's going to cut wherever I select it. And that's all. I'm going to leave everything else out of the box. I'm going to say OK. Calculates, and it gives me this adaptive clearing toolpath. Really good algorithm. Great toolpath strategy for roughing and removing those chips efficiently. And I'll get into that a little bit here. So here, you can see the tool is going to helix its way down. I have a taper helix. Tapering your helix into the material is going to leave room for swarf to get out. And it's going to keep it from recutting those chips and work hardening the part. So as it works its way down, it reaches the bottom of the pocket. So once it reaches, and you're using as much of that flute length as possible, it's going to start working its way out into the pocket, keeping that same chip load on the tool. You keep the same size chip being pulled out, you can control the heat that's being pulled out with the chip. Okay? And you're keeping your tool engaged as much as possible in the most efficient way. So you're keeping that optimal load, the same load on the tool. Traditional tool paths will follow simply this offset. And when it gets into these corners, you can really hear your tool scream as it gets into corners because you're probably going linear. You're probably about 30% tool engagement. But once you get into that corner, you start to see 60 to 70%, and that's where your tool breaks. Adaptive clearing is going to remove that or at least eliminate the possibility of that tool breakage by keeping the same chip size. The tool is going to keep the same load on the tool the entire time. It's going to work its way into that pocket, and where it can't keep the same chip load, it lifts out, comes back in for another bite. It'll continue doing that until it gets all the way into the pocket where it gets the smallest bite, saving you a lot of tool life right there. Okay, you can raise your speeds and feeds because you're controlling the load on the tool. You're controlling the heat that comes out with the tool. You can run at higher speeds. Higher feeds and speeds are going to get the parts off a lot quicker, and you're going to save your tool life. Same thing here. The open pocket, keeping that same chip load the entire time. Let's take a look. So I'm going to highlight Setup 2, go up to Simulate. Okay, and we can show it with all the toolpaths on there. We can also show tail, so it only shows where the toolpath has been. Okay, so I'm going to hit play. We've already seen it do the face, so I'm going to fast forward to the next operation. And here it's working its way in, doing that constant chip load, working its way into the material. I can actually grab a hold of this bar down here, and I can move it into the toolpath wherever I want. I can also back it up. You move it into, I'm going to do this little helix into the closed pocket. Now if I back it up, I can restart and it recalculates right where it was. Really, really good simulation engine. You can slow it down a little bit. You can even make it go backwards into the toolpath, recalculate where it was. So you can really go in and see what that tool's doing. Really good simulation. There you can see it going into that pocket, using that constant chip load, keeping that as much of that flute length, keeping as much of that radial engagement in the material as possible. Going to save you a lot of tool life, save you a lot of time on the end of the machine. Okay, so we're going to fast forward and go through that a little bit more, and then I'm going to show you what it looks like to colorize it too. So I'm going to close out. Now, the next thing I want to do is I want to cut. I like the way that was set up. I like my constant load. I like the way the toolpath is set. It worked really well for the pockets. Now I want to choose the same adaptive to be able to cut from the outside of the part in. So I'm going to right-click on the adaptive that I just did, the 2D adaptive, go down to Copy, right-click on my setup, and paste, and I made a duplicate of that same toolpath. This first one I'm going to soft click. I'm going to call this one pockets or adaptive pockets. Well, it's called pockets. And then for this one, I'm just going to call it outside. Okay, so for my outside, all I have to do is right click, edit, and I'm going to change the geometry. Instead of being those pockets, I hit the X here. I'm going to choose just this bottom edge. Notice that it's selected and it knows that blue area. It knows where the edge of the stock is. So it calculated the edge of the stock and knows where the toolpath is going to be. Now, I wanted to get as close to my soft jaw as possible without hitting it. So what I'm going to do is I'm going to go into my Heights tab. Really easy to work with, color coordinated. You can actually grab a hold of these heights and move them around. What I want to do is I want to move the height of the bottom of the tool as close to that soft jaw. So I'm going to go down to bottom height. So you have these different choices, and there's that in context help when you need it. So I'm going to choose selection, and I'm going to select the top face of that soft jaw, and it drops the bottom of my tool down to the soft jaw there. A great way to control the height of your tool. Now I don't want it to drag on there, at the bottom of the tool to drag on the soft jaw, so I'm going to add 20 thousandths. And I raise it up 20 thousandths, and I'm able to control the height of the tool simply by dragging or selecting geometry. The Passes tab. This is what controls how much we're engaged. There's our optimal load. That's how much the engagement, that's the actual optimal load that you would use as you calculate your feeds and speeds. That's our radial engagement. If you right click, you can edit the expression. This is what's driving that optimal load. Your tool diameter of the tool you selected multiplied by a factor. And you can easily go in here and change that factor. I'll make it 40%. Okay, recalculates, and there's my new optimal load. Really quick and easy to use and easy to work with, being able to change your parameters. Here's how much stock we're leaving on the floors and on the walls. I'm going to say OK, calculates. I quickly have the adaptive clearing toolpath on the outside of the part. Okay, so let's get some code. I want to run this in my machine. I'm going to get some drills in here real quick, and I'm going to rough it out in the machine. So I'm going to go up to my drill toolpath. Okay, go into drill. The same workflow, except now we have cycles versus passes and leads. That's okay because our drill cycles start with our drills start with cycles and end with a cycle. So I'm going to select the tool. If I forget what the size of the hole is, if I just hover over a hole, Fusion will tell me. That one's 1/8 of an inch. This one is 0.625. So I can get an arc. If I forget what the size of the hole is, it'll tell me. So I need an 1/8 inch drill. So I go into select my drill. I'm going to have an 1/8 inch drill. It's a good idea to select a library or create a library that matches the tools that you work with. I have a library that I created for all my aluminum tools. I have tools that are on my Hsm machine. It's a good idea to create a library of tools that match your work. So here's an 1/8 inch drill I have in the machine. Select it, brings it into my graphics view so I can see what it's going to look like. It's the right drill. I'm going to select those holes. Go to Geometry. I'm going to select this hole. Now, you might have a plate that has 100, 150 holes, and you're thinking, I'm going to select every one of those holes. Come on. Well, we have a function where you can select the same diameter, and it grabs them all automatically that are in the same plane, the same diameter. Really, really helpful, handy function to have. Your heights, I want to make sure I drill the tip through the bottom of the hole. So we have a function that says drill tip through bottom, and we can add an offset. Let's say I make it 0.050, so I'm going 50 thousandths past the hole. So you don't end up with that little chamfer on the inside of your hole. And then my drilling cycles, a lot of these work very well for my Hsm machine. My chip breaking, I get the IJ, the Q value for my chip breaking. It actually shows you the PEC. So let's make a little bit of a small cumulative PEC. Let's say it's 10th. It's going to say OK. Calculates, and when we do our simulation, you'll see, I'm going to go up here and simulate. I'm going to simulate it by operation so we can see it in the material. If I go to play, I can jump through. Okay, I can actually even select the operation up here. It doesn't look like it's doing the colorization like I thought. Let me close it real quick. I think I might have selected it or something happened, but I'm doing it by operation. That's good. All right, let's go try that again. I'm going to go to play. Okay, I'm going to jump through. This should be blue. There we go. And now the outer should be yellow, so I'm able to see. Look at that, using as much of that flute length as possible, keeping it engaged as much as possible, keeping that same size chip coming off the material. Really, really good roughing strategy right there. Okay, so I'm going to go into the next. There's my PEC. It's showing me my PEC drill right there in simulation on my part in Fusion. Really cool. Okay, we can fast forward through there just by grabbing a hold of this little bar right here. Okay, let's get some code. So I'm going to close that out. While I have setup 2 highlighted, I'm going to go up and get a quick setup sheet so I know how to set up those tools on my machine. I'm going to save it in a project folder. You can save it in your A360 as well, but I'm going to save it locally in a project folder. And it gives me this right out of the box, this HTML setup sheet, showing me my part, where it's sitting, where my G54 is. There's my datum. So if I set up my assembly correctly, all I have to do is plug that in my machine and I'm good to go. Down here we have the totals of how many tools we're using, which tools we're using, our maximum feed rate, maximum spindle speed, estimated cycle time for the whole program. Down here, each operation, how to set up the tool, which holders are we using, what's our length offset, okay, what's the estimated cycle time for each operation down here. Okay, really good setup sheet right out of the box. Okay, I'm going to minimize that. Now let's get some code. So I go up to setup. I have it highlighted, setup 2. Let's go to post process. That's okay. I have an update. That's okay. I'm going to say yes, reset it. I want to make sure I'm using my generic posts because that gets updated each time we have an update for Fusion. It updates all the posts, which is a good thing. If you don't find your post in the list, you can go down here and you can do a search online in our post library for your post. You can look by vendor. You can look by type. Really good. They keep this updated all the time with the latest posts. Quick and easy to be able to find your post, download it, and run it. My Hs VF2, the Hs generic post right out of the box works great for my VF2. I have some switches down here I can choose, whether I want to see an optional stop, if I want to have a preload my next tool so my carousel comes around, saving me some time. Sequence numbers if you want them on or off. Use G28 versus your G53. Down here we have use radius versus IJ and K. Write the tool list on top of the code so that the operator can see all the tools. So I'm going to leave them all out of the box. I'm going to go to post, save it in a folder. I'll save it locally. And I get this posted code that I can save on my thumb drive, bring it over to my Hs, and run that part right now. Now, wait, I just realized it's not the right part. I have the wrong part. This is the 5-hole configuration. I need the 3-hole configuration. Shoot. Now I've got to go back and make a change. We're going to go back into the model. We're going to actually open up that model. This is the linked model. I'm going to go in here and just simply open it. And I open it in Fusion. Now, Fusion is great. You can do a lot of your P-spline modeling. You can do sculpting. This one was done with a lot of parametric modeling. So we have sketches. If you're used to software, you know, CAD software where you have parametric sketches, you can see your history here. You can go back in time of your history and find out how the part was made. And you can easily make your parts and design them the way you're used to parametrically. So in this case, what I want to do is I want to be able to change this pattern right here. So this pattern, I want to edit that feature. Let me escape. I'm going to go in here, right-click, edit the feature of the pattern. Instead of having the 5-hole, I'm going to have the 3-hole pattern. I'm going to say OK. Okay. I'm going to shrink the part a little bit to what it's supposed to be. So I'm going to edit this sketch and just right-click. I can also do it right here. Right-click, edit that sketch. This is the sketch that defined the shape. And I'm going to change this from 1.40 to 1.25. So it's 1.25 inches. Stop the sketch, the part stretched. It now has 3 holes. I'm going to save that part. I'm going to say changed holes and length. It's a good idea to keep your changes, define them really well so other people working on your team can see exactly what changed. Save it. Okay, I'm going to go back in, I'm going to close it out, and you see there's an update now. Something has changed. So I'm going to go up here and update the model. You'll see it'll change to the new 3-hole configuration. And it's going to change the length of the part. Now, if I go back into CAM, you think, man, I got to select all that stuff again because it thinks I have 5 holes in a different place. My pockets are in the wrong place, and it's cutting the 5-hole configuration. Well, if I hit Setup 2, I can right-click, Generate Toolpath, and it automatically updates Oh, it's going to make a liar out of me. I think I might have selected something there, but it automatically updates to the 3-hole configuration on my adaptive clearing. Let me see what I did with my drills. If I edit that, okay, I can simply go in here and I can select the hole. Something went wrong there, maybe the way I selected, or it could be in the software. But I can easily get back, right-click, I know exactly what I'm working with because it's always the same workflow. Go in here and select my geometry, say OK. That quick, I'm able to get it back. Okay, you can do that in all the toolpaths because it's always the same workflow. Real easy to get to your geometry. Easy to use, completely integrated. So I'm going to go up to Setup. Okay, I want to be able to post that same code, so I'm going to go up and post out the new part. In fact, let's do this real quick. I'll go up here and simulate it. Then go to Play, jump through. You can see it's simulating the 3-hole configuration. That's what it's going to look like. So I can see it real quick. Yes, that looks good. Now I have my 3-hole configuration. Close it out. Let's go post out that code. Post process. I'm just going to say OK, overwrite what I did before, and I get the new code that's going to have the 3-hole configuration. So super fast. We're able to make changes in the interface. I'm able to get code out really quickly. Always the same workflow. It's always easy, the same workflow to walk through. And anytime I ever make any changes in here, if I go to Edit and I want to change, let's say my stock height, instead of leaving a 1/10, I'll leave a 1/4 on the top of the part, make a change, regenerate, that quick, it's going to recalculate my face toolpath. I want to make sure I take that in steps. Let me go in here. I'm going to say in my passes, I want to make sure I do multiple depths, and let's say 50 thousandths at a time. Say OK, recalculates, and it knows how much material is on top to be removed. Real quick, real easy to use, completely integrated CAD CAM. So that's Fusion. I think I might be around on time, guys, if it's okay. That's really what I wanted to show. There's a couple more things we can talk about, but I don't want to go over time, guys.
No worries. If anyone has anything specific, feel free to leave a question, and if we have some time, we can go over it. We've got a couple of minutes here, but we'll go ahead and jump into some Q&A here. Real quick, Wayne. Again, thank you for that amazing demo. I know that when I was in school, I would use a separate CAD tool than my CAM tool, and it became a huge problem, especially when parts were being edited or features were being changed. I'd have to re-import all of that and then create code again, which would be really annoying. As opposed to this, where you just go ahead and update those toolpaths, and for the most part, it's smart enough to go ahead and grab all of that new information for you.
It is actually, and if actually I would like to show something on that, and that's a good point. Where I was selecting 2D geometry, these are 2D toolpaths to be able to select there. What would make that process easier, as you had mentioned, was being able to make a change in the geometry and have the toolpath automatically update is huge. We also are able to work with our 3D toolpaths. So the difference with that would be 2D toolpaths require you to select 2D geometry because what drives the toolpath is 2D lines, splines, arcs, and sometimes points. The 3D toolpaths are driven off the surfaces, faces, and edges of the part itself. So we can actually use a 3D adaptive. You have 3D adaptive clearing. I can actually just, here, let's do it on this one. I'll do a quick setup really fast. So I'll do a setup. I'm going to choose this part. Okay, I'm going to do my stock. Actually, my setup is good. I'm going to leave it in the middle. I'll add a 1/10 on the top. We'll add 1/8 of an inch around the sides. Oh, sorry, this is the side. We'll leave a 1/10 on the top, and then we're going to leave a 1/4 inch into the part. So real quick, I'd like to show you, instead of having to do that with the 2D toolpaths, if I go up to 3D, just select the tool and say OK. It looks at the model, and it looks at the best approach that it can take, the most efficient toolpath you can get to remove those chips. It looks familiar. It looks like that the very familiar of the toolpath we selected, but it's catching all those places where that tool can go most efficiently. So if I look at that, I'm going to do a quick simulation. And let's play through it. And as we play through it, we can see that it's giving us, even on this parametric part, or on a 2D type part, it's still giving us that great adaptive clearing. And you're going to be able to get there just simply by selecting a tool. I did a setup on the part itself, selected a tool, and I'm able to get that roughing on there. I can do the same thing. If I did a horizontal, I can clean up all the floors, and I can do a contour and I can clean up all the walls. I just simply went in and selected it, used the same tool the entire time. There it's cleaning up all the floors, and there it's cleaning up all the walls. Real simple, easy to use, and of course if the part changes, it'll update all the toolpaths automatically.
Definitely, for sure. So we have a question here from Kevin. Kevin asks, can you enter a burned template of a part outline from base stock to reduce rough cutting?
A burn template of a base part. So yes, I think if I understood your question correctly, are you working from a solid model that's going to represent your stock? If so, yes, you can do that. You can have a solid model that represents your stock, or if you're saying if you have a sketch, you can even have a sketch represent the outline or the perimeter of your stock so you can reduce excess cuts. So yes, you could do that as well. When you do your setup, you're simply going to go in and in your stock setup, for your mode, you can say I want to have from solid, and you can select that geometry. Also from your relative size box, you can also choose your offset mode as well. So you can do that from here, from solid or from a selection inside your solid model.
Perfect. And then we've got another question here from Scott. How do I create a new tool? I use a CNC router, and I'm able to use tools that are different from standard. And then he mentions that Fusion seems to define the operations that I can do with a specific tool.
Okay, so if you go to the tool library and you create your tool library, here's my aluminum list. I can create a new library. Let's say I go into here. I'm going to say local, say new tool library. I'll call it Wayne's library. Oops, if I could spell. There's Wayne's library, and in here I can right-click, or I can go to Wayne's library and I can create a new tool. Let me. I have it highlighted, new tool. So here I can select the type of cutter that I want to use. I have ball end mills. I have chamfer cutters. You can select your cutter from doing a radius mill. Then I can plug in the values of that radius mill. So if my diameter, let's say it's a 1/4 inch radius mill, I have a 1/4 radius of a 1/16 will work. Shaft diameter, 1/4, and tip length. So you can really define your tool right here. As you go across, you can also select the holder. You can also define a tool holder library. Your feeds and speeds, you just plug in and say OK. You want to give it some more information too for your post processor. What's the tool number? And I can say this is a radius mill, 1/4 inch, like this. And then I can say 3 flute. And say OK. Now I have that tool that I can use in any toolpath. So that's a quick way to define a tool. Just to let you know, today it's not in there yet that we can have it create the tool from geometry, but our development team is working on that, and it should be an update in the near future to be able to work on a custom tool shape.
Definitely, and that's one of my favorite things about Fusion is they're really transparent about how they're moving forward within the product. Things like sheet metal they're working on right now, and this they're pretty transparent with what's going to come out in the next couple of weeks, and then they release. For those of you who don't know, they release updates to this, quarterly or even sometimes more often than that. So you get new tools all the time. You don't necessarily have to wait for that big old release like you do sometimes.
Right, and that's available on the website. Yeah.
It is. I'd like to show you real quick while we're here. If you go to our main website, which is our cam.autodesk.com, and in here you can go to our forums, and in our forums there's a section here where it's our idea station as soon as it loads up on my computer here. So you have our forums, really great support forums, working with posts and working with supports. So we have this ideas. So this is our Inventor HSM. We have it for Fusion as well. But I just jumped in, I'm so used to the HSM one. But we have it down here for Fusion. So if you're working with Fusion or Fusion CAM, we have Fusion 360 there, right down here. We're also working with CAM, so if you go into HSM, it's the same exact CAM. So HSM is really covering the CAM, the algorithms, the developers. They're working in the same exact engine that you find inside of Fusion is the same engine you'll find inside of our HSM Works as well as Inventor HSM. So if you look in here in HSM Ideas, these are places on the CAM side where people are asking for things like here, 3D tool holders for manufacture. Can you import them? These are ideas that people have, things they'd like to see in the software. You can enter them here, and if enough people vote on them, our development team will then take that seriously. They'll add it into their development milestones, and then you'll eventually, well, pretty soon they update it like the team has mentioned, that Nigel mentioned, that they do an update very often in CAM as well as in Fusion. And that's one of the beautiful things about Fusion, is that you don't have to wait for next year's update to come around. It's constantly being improved. And these things are really what drives it. It's the people using it. It's us. It's us putting in our ideas and things. How is it working? What's your feedback? What would you like to see most? And you can get votes. If other people agree, I'd like to see that 5D chamfer. If enough people agree, I don't know what the number is. I think it might be 99, but I might be wrong about that. But if there's enough people that agree, they'll add it into the next update, or they'll add it into the milestones or their workflow for the next update. So a really great place to go.
And they have idea stations for a lot of the Autodesk products. It's one of the really cool things about Autodesk. They kind of listen to the user base in regards to what you want them to implement into the products. It's not just Fusion, it's everything. So I know one of the really big ones for the last couple of years was the PDF import into AutoCAD to get that vector data to geometry, and they made it a reality for 2017. So definitely, if there's something that you really want implemented, make it a reality by going to the idea station and then you can get all your friends to upvote you. So,
That's right. Just to mention really fast, another great website would be our Autodesk Knowledge Network.
Yep.
If I could spell. Autodesk Knowledge Network, a great resource to go to. You can Google it right in here, and you can find your products for Fusion 360. If you're looking for CAM and Fusion 360, you can go in here and do a search, and you'll find a good feedback for CAM, walkthroughs in CAM, our environment. You'll see tutorials you can get to. So there's a lot here right in our Autodesk Knowledge Network that'll help you get started working with our CAM.
Definitely. And along the same lines of, Autodesk kind of listening to the customer base, we do have an event in December, which is the Inventor Gunslinger event. You're going to get a survey after the webinar. One of the questions is, are you interested in coming to this Inventor Beta event in December? Say yes if you can. It's super awesome and kind of exclusive, where you can come with the Autodesk team and with the product managers themselves and developers, work in a beta version of the new software. And give your feedback, and they're definitely looking for ways to improve the software before the release. So definitely something to look for.
Yeah, and again, that's a really exclusive event, and those usually people sign up for that pretty quick. So if you can attend and want to be a part of that and give your feedback, again, you jump on it.
Yeah.
And I think we already have a page where you can sign up for that. Is that right?
No, not necessarily. We don't have a page yet where you can sign up for it. It's a little far out. Okay. But I do have a list of interested people, and I am starting to call a couple of those people. You might have heard from myself or someone else here at KETIV about interest for that event. So that's it. If anyone has any more questions, we'll give you another 30 seconds or so to type those last ones in there. And then it looks like we got another thing from Pete, Pete Dixon. So Pete mentioned that we've got this really sweet poster behind us, and I'll show you real quick here on the camera. So it's a Landa poster from one of our customers. We have, about a dozen of these in the office, and we're kind of rotating these every couple of weeks for AVA. So if you have something from your company that you want to, share with the world, feel free to send me the picture, and we can get some of these made for you, and kind of showcase everything in that sense. Definitely want to grow a community here, and we want everyone to get some exposure in some sense. So with that, I want to remind you all that we do have that Future of Making Things Fusion Lifecycle event, and that's October 19th at the Bowers Museum. I did post the link in the chat. If you didn't get it or you need it again, feel free to let us know via email or by calling us. If you're interested, we'll make sure you get that information. I can't stress enough how exclusive this event is and how much of an opportunity it is for you to be able to see, through the eyes of the visionary himself, technology moving forward. Again, I'd like to thank Wayne for being here today. It was a great presentation. If anyone gives me any, if you have any crazier CAM questions, that you think might take a little bit longer, feel free to ask those in the survey. I'll definitely get those forwarded to Wayne if I can't answer them myself. Thank you again, Wayne, for being here.
Absolutely. Thanks for having me, guys.
For sure, and I definitely hope to do one of these in the near future. Maybe do some crazier stuff here in Fusion CAM. There's definitely, as new things come out, we might do some more sessions, because definitely the tools are awesome. I love it.
Yep, sounds good. We do have more multi-axis coming up in the near future, so it's going to be fun stuff.
For sure, and maybe we'll make a series of Fusion CAM AVAs, and we'll call them KETIV's AVA Wayne's World. And I'll wear the hat and I'll sing song and everything. It'll be great.
It's party time.
Sounds good. All right, then. Thank you all for being here today. And if you have any questions, feel free to let us know in the survey. We'll catch you later next week.
Thanks, everybody.